We are exploring the exponent laws. Now, our product law means anytime you multiply identical bases, x and x are the same base, you add the exponents. So x to the m times x to the n is x to the m plus n. Your quotient law says if you're dividing identical bases, so x to the m divided by x to the n, remember x is the base, you subtract the exponents. You power over power law. If you have a power here, x to the m, and you raise all of that to another power, you multiply the exponents. And anything to the zero power is equal to 1, or anything to the zero exponents equal to 1. Now, these are the laws we're going to apply for the rest of this lesson. So let's look at these examples. It says write as a single exponent. This is power of a power, so we're multiplying the exponent. We don't change the base, so that's 2 times 4, and that's why this is equal to 3 to the 8. For this one, we're multiplying powers with the same base, x and the x. Most of the times we don't write the multiplication sign between them because you might mix up your x with a multiplication sign. If there's no exponent on it, the exponent is 1, because anything raised to the power of to the exponent 1 doesn't change it. So x to the 1 is still x. So what we're doing is we're adding the exponent. 2 plus 1 gives us 3. And then we're going to look at the next one. X to the 5 divided by x squared. When you're doing a division, you subtract the exponents, and that gives us x cubed. And that's how you'd work through these. Now let's review some of our terms. If you have 2x cubed, 2 is the coefficient, x is the base, and 3 is the exponent. So I'm going to be using base, exponent, and coefficient pretty frequently throughout the rest of these examples. So let's continue with these examples. I'm just going to explain what's being done here. We're dividing 20 by negative 4, and that's how we get negative 5. If there's no exponent on the letter, or 1 is always there, so we have x, and 5 minus 1, that's how we ended up with the 4. So you divide the coefficients first, and then you would work through the variables. So negative 36 divided by negative 9 gave you 4. There is no exponent on the a down here, so 1 should be there. 2 minus 1 is 1, but we never write the exponent 1, so we just erase it back. And the other example, 100 divided by 10 gave us 10. I think that's a typo here. I'll fix that typo soon. And 8 minus 5 gives you 3. And for these that you were supposed to be trying on your own, remember you divide the coefficients first, and then you work on the exponents separately.